Akhil sir.
Yes, sir.
Can we start then?
Yes, sir, we can start.
Okay. Umashankar sir, I'll just give a brief intro and then we can start, sir. Dear participants, welcome to the last day, that is the sixth day on smart energy storage technologies from research to practice. Today we have Dr. Umashankar. Dr. Umashankar Subramanian, professor contributing to teaching, research, and academic leadership in the field of electrical and electronics engineering at one of the India's leading institutes known for excellence in education and research. He was a professor at Prince Sultan University, and now he is currently in Amrita Institute. So he is also a part of 2030 International Steering Committee for Global Ranking and a global distinguished expert at Global Education Policy Network towards Sustainable Development Goals. He is a chair and co-chair. He has been a chair and co-chair of international workshops and prestigious conferences. Previously, he worked as associate professor and head of the Department of Energy, VIT Vellore, and has 22 years of leadership, teaching, research, and industrial R&D experience. He was vice chair IEEE Madras section and chair IEEE student activities from 2018 to 2020. He was an executive member 2014 to 16 and vice chair of IEEE MAS Young Professional from 2017 by the IEEE Madras section. He also has done collaborative government grants and industry research projects like Sustainable PSU Campus and Sustainable Microgrid and Eco Charge e-vehicle development. AI-based prediction and condition monitoring, AI-based fault diagnostics, power quality audit in Southern Railway, EMI, EMC in solar PV inverter, power quality analysis of industries with Inphase, Bangalore, Emerich Energy, Chennai, wind solar hybrid system sponsored by MNRE in with CWET, Kayathar. Related and for joint energy management projects, smart energy metering and EV mobility and charging infrastructure for EVs funded by government industries. He is a well-known personality in the electric vehicle, power electronics related stuff. So today, Dr. Umashankar will be talking on sustainable, smart grid and energy storage, EV charging infrastructure. Uh, so I welcome you with all due respect, sir. I welcome Dr. Umashankar to do the presentation. The meanwhile, I would request all the participants to stay in mute. And in case you have a question, please raise your hand. Thank you.
Thank you, Professor. So it's my pleasure. So I'm engaging with GCA Kannur like almost last 10 years, starting from Dr. Jayaprakash. So he was my doctoral committee member as well in my PhD. So, and almost I'm collaborating with the GCK, and I'm also part of almost maybe 4 or 5 conferences which is happening in GCK. So thank you, and it is something like my second home apart from my present institution. So the topic, in fact, I supposed to give on Tuesday, but in fact I had the final exam started, so I'm unable to give on that day. So that's the reason. So thank you again for giving me the opportunity on the last day. So the topic itself is the energy storage related and research, what is happening in this area. So in fact, if you see that the energy storage is not an new topic, which is a almost 10 years old topic, and but now why everybody is talking about energy storage? It's because of the EV charging infrastructure. And moreover, if you see that the government is also demanding a lot of EV charging infrastructure facilities, especially some of the top companies also involving like Tata BP or Bharat Petroleum or HP, okay, Indian Oil Corporation. So everybody is in place so that they want to have the EV charging infrastructure to accommodate whatever the vehicles capacity is growing like anything, like last 5 years up to 2025. And if you look at the projection for 2030, that means the next 5 years, it is enormous. So that's the reason. So this energy storage, along with the sustainable smart grid, is a very important. So now, if you look at the state-wise electric vehicles, so as on date, like this data was taken on August 2025. So this is the particular data and state-wise also. I hope Kerala also accommodating around 160. This is coming in the top six. So if this is the case, so if you look at the growing numbers, okay, especially the installed PCS and EVSEs, which how many numbers they deployed and how many operators are there. So if you look at this count, so you will immediately it will click in your mind that so it is going to be enormous in the next 5 years. It might be multifold. So when we talk about the energy storage, so there are two kinds. One is battery, another one is a fuel cell. That means a hydrogen-based fuel cell. So these two are the very much promising one in the coming future, and especially if you see the Western countries as well as in the like China as well as in Australia, they already deployed this kind of energy storage facilities along with the grid. But now, if you see that because of the huge deployment of renewable energy sources in India, and that too, all the renewable energy sources are intermittent in nature. So definitely, so you need the help from energy storage. So this is mandatory nowadays. So when you look at the renewable energy, either you need to go with the fuel cell, and the fuel cell you can use it with the electric vehicle, or you can go with the battery, and battery you can use in electric vehicle. So this is the two options now. If you look at the battery capacities worldwide, if you see more than around 400 gigawatt hour per ampere lithium-ion battery cell production capacity, which is happening especially in the Europe itself. So if you look at the different kind of batteries in this, if you see like a EV battery, hybrid electric vehicle battery, or long cycle life battery, or plug-in hybrid battery, so all these kinds are coming into picture. So if you look at this, so which is very important, because the EV battery is very important because you are going to use with the long range. So let us look at one of the technology which is deployed in Ashok Leyland. So it's called smart battery swapping solution. So mostly if you see the Ashok Leyland, they got this with the help from the Sun Mobility, and they have adopted this. So you can see the battery swapping technology as well. So this factory is of course in Chennai. So within a fraction of seconds, so it is able to swap the battery. So this is something similar like a smart battery, and you can easily upgrade and you can easily interchange, swap. So that too, if you see that within 3 minutes. So this is what the advantage of going with the swapping technology. So if that is the case, so almost if you see each state government, they have already deployed a lot of electric buses as well. So mostly either it is depending on the charging facility, or it depends on the battery swapping facility. So if you look at the different locations, like maybe this is started in India during the COVID time, India's first public EV charging plaza. But now if you look at everywhere, every state and every highways, you can see a lot of EV charging infrastructures are available. But the only issue is whether it is really green EV charging or not. So that's the challenge. And this is one of the Xeon electric vehicle charging facility you might have seen in the highways. So usually, if you see how the charging infrastructure, especially in the house as well as in the office premises. So in the house, if you see that you should have the facility to charge your EV, especially if it is not only from electricity board but also from the renewable, it is a good. Why? Because it should be like a green EV charging, so that whatever the charging is happening, it is from the renewable. That will be better because anyway, if you take it from the power grid, most of the electricity board power supply is from your what do you call thermal power plants. So that is not green or clean. So that's the reason. So you should have some renewable in your place itself, so that it will be something like a green EV charging infrastructure. And for this, if you see that even office premises also, you should also have these facilities. And I hope most of the industries nowadays, even the IT parks also nowadays, they have this uh, renewable energy based uh, distributed energy resource, or you can say microgrids available. In fact, even in Kochi Tech Park also, it might be there. Then another important thing is the parkade structure. So wherever you have a car parking, so it is equipped with the renewable based solar PV based parking, so that you can charge your electric vehicles. So if you look at the Indian EV market, especially what we are focusing is batteries and battery charging. So this is nothing but the big business in India, especially it has a lot of scope as well as a lot of business in the coming years. So if you look at the cumulative potential up to 2026, like it is starting from 2017 to 2025. And overall, if you like by 2026, if you look at, so you can see like how many EV chargings, how many to be installed, especially how many AC slow charges, how many DC fast charges. So these things and all, like it is like if you look at the projection, it is enormous. So how you are going to deal with this EVs in the near future? So you should have enough EV charging infrastructure, especially the green EV charging infrastructure. And our government is also has some lot of announcements that they have done like last 5 years. Especially you might have come across these schemes like National Electric Mobility Mission Plan, or you can see that fast adoption and manufacturing of hybrid and electric vehicles, a FAME scheme. And apart from that, a lot of private operators also, as well as the public sector companies also, they are involving in this, like NTPC, BHEL, ESL, Tata Power, Ola. So they are also in the place. So if you look at this, so another 5 years projection, if you look at it, it might be multi-fold. It may not be double. It might be multi-fold. So when you talk about the category wise, especially if you see the uh, different vehicles, starting from two-wheelers up to three-wheelers, private vehicles, commercial vehicles, and buses. So there are a lot of players involved, like starting from Mahindra. So Mahindra, they have auto also, that means three-wheelers also, as well as private vehicles. And not only that, they have like nowadays they are focusing on trucks also, especially the EV trucks and EV buses. So mostly they are either depending on short-term like a charging infrastructure, or long-term. If you see, either it could be like a public charging station, or it could be like a battery swapping. Battery swapping, if you see, it might be useful for two-wheelers and three-wheelers, but also useful for the like small mobility buses as well. So you can see almost three categories it requires the battery swapping facility. But also, if you see parallelly, you need the public EV charging infrastructure. So this is also another important one you need to focus. But really, are we able to achieve this or not? So that's the biggest question nowadays. So the world in next 40 years would require far more energy, but in an ever more sustainable way. How it is possible? So in next 40 years. In fact, if you see that This is given by Jean Pascal Trigori, CEO of Schneider Electric. It's nothing but next 40 years, energy consumption will be double, and at the same time, you need to half the CO2 emission. That means there is a lot of climate change issues are happening right now. If you want to achieve these two, that means your system should be 4 times more energy efficient. So energy efficiency is also another important parameter in the coming years. So you should not only focus on renewable or smart grid. So energy efficiency is also matters. So this energy transition, if you see that how it is going to happen, like most of the places in India, if you see, like 70% of the new installation, it is from the solar and wind, especially starting from 2012 to 2040. 2040 means still we have 15 more years. So if you see that how it is going to be like growing, especially the total installed capacity in gigawatts. So if you see the solar and wind, yes, it is like a huge growth. But at the same time, if you see the others also contributing much, others means it is including the conventional thermal and nuclear, etc., etc., and also some little bit biomass. And here only you see that why you should have energy storage importance is coming into picture. And another thing is that countries like India, if you see that electrical infrastructure, if you see most of the places like in villages and all, it is still old infrastructure is there, and it is not renewed, okay, or restructured. So the restructuring is another important part because all your renewables require you need to pump the energy which is or the power which is generated from the renewable, and you need to evacuate that power to the load center. So that is very important. And if you look at this picture, you can understand the demand is like a huge, whereas the supply is unable to meet. So the supply and demand must be same. So how you can do this? So that is also another important question. So energy consumption, if you see that like another 10 years, like 2035, you see that it is growing like 27%. And if this is the case, how you are going to meet this energy demand is another biggest question, because most of the things are digitized, and now if you see that AIs are coming into picture, AIs require a lot of data center, and all the data centers requires continuous power supply. So it also requires the air conditioning system. So you just imagine about how many data centers will come in the near future. So there is a lot of energy requirement in the near future. So if you see that we need to understand about the grid equation. So grid equation is very important. The grid equation, if you see, it has some key drivers as well as main contributors. So what is mean by the key drivers? The key driver is nothing but the growing electricity demand. So that is nothing but the key driver. But at the same time, as Jean Pascal, the CEO, said, you need to focus on how you can reduce the CO2 emissions by half. And not only that, you also have a challenges like existing constraints in the networks. That means the electrical infrastructure. So how you can modernize or renovate, restructure. So that's also a huge challenge, especially countries like India. But if you see the another side, the technology, what we have now is like it's mind-blowing technologies are there. And the government as well as the regulator are also actively participating now. I think you might have seen a lot of discoms and Pusoko, they are also actively involving in this. And not only that, now the end users like us, like customers, they also know very well about each and everything what is happening really. And you are able to track your energy consumption also by using a mobile app or something like that, by using your electricity boards application platforms. So if this is the case, so I think this is very much possible. So you can make it happen. So far, if you see that, so how you are getting the electricity. So you might be knowing, I think it's not a new one. You might be knowing very well. So how you are getting the energy, especially from the grid? So it's a one-way energy only grid. But if you look at now, what is the transition is happening? Everything is based on data now. Okay, the data is asset now nowadays. So most of the locations, if you see that they converted to two-way energy plus a data smart grid. So that's what they did it now. So especially if you are thinking about the conventional centralized power generation stations like thermal, nuclear, where you have the evacuating infrastructure, then transmission lines, then distribution lines, and distribution station, substation. So like that, you will be getting it. Okay, this is what the usual structure, right? You will be getting the power. Uh, so now, if you see that the government has a lot of policies to install the renewable energy plants as a centralized power generation, also like a bigger power plants in terms of gigawatt, uh, or you also have a distributed generation like the distribution substations as well levels, or like most of the state governments also they are encouraging to install the distributed generation in their customer premise itself. So if this is the case, so in almost most of the locations, the renewable energy is coming into picture. So if this is the case, so what is the one important thing is the consumers also active nowadays. Active means like they are aware of it. They have a lot of exposure. So if this is the case, so how you can to meet the demand, energy demand for the next 5 years, especially targeting for the electric vehicles, okay, two-wheelers or four-wheelers. So that's a very important thing because you need to have charging stations in your home as well as in the office premise or wherever you go. For example, if you're going for supermarket or mall, you should also have this EV charging infrastructure. So wherever you go, this facility is supposed to be there. So how it is possible? Because this latest technology, okay, data smart grid. So the data smart grid is nothing but it is giving a very energy efficient, and if you see that it is able to act very quickly, so that's another advantage. And it is a localized, like the distributed generation units are localized. You may not have much transmission losses like your conventional power generation. So that's the biggest advantage of going with this. And now, if you see, not only that, so in communication technology, also a lot of things are happening. For example, now we have a 5G and 6G also. It's in place in almost few of the countries, and there is a lot of research is also happening beyond 6G. So why they want it? Because they want to have like very fast communication networks and network protocols so that it can be easily communicating with distribution substations as well as with the consumers. So that's the advantage of going with this. So if everything is in place, so what will happen? So you can see that you are making uh, consumers more active, and you are making a distribution substation or generation is something like flexible to meet the demand response, and you also have a renewable reserve in place. So if this is the case, so everything is possible. So now if you focus on like how this is going to be happen, like renewables, yes, of course it's a clean and green, but the only issue is like it requires like uh, solar requires only the daytime, especially if there is any cloud, it may not generate, so it is an intermittent source. Wind is also, it depends on the wind. So it is also intermittent. Biomass also, it depends on the materials which is available. So since everything is intermittent, so you cannot depend on a renewable like your thermal or hydro or whatever you say nuclear. So these are like base capacity. So they base load they can operate it. But whenever there is a change in load, you can use this renewable nowadays. But in future, if you see that if all are renewable, how you are going to manage this intermittency? So that's the challenge. So now, if you look at it, this is the recent data which I collected. So if you look at the install capacity, non-fossil fuel and fossil fuel, means renewable, renewable is dominating more. And if you look at the solar, it is coming around 20, wind is coming around 18%. Still, if you see the coal is dominating like a 76% PLF, plant load factor. So that's the issue here. And rising power demand, if you see uh, like 2025, it is 250 gigawatt. But if you look at 2032, it's coming around 360, right? And what India should focus is very important now, this point. So why the energy storage is very important. So by 2032, see, coal, as long as the coal is there, so it is able to maintain the base load. Okay. So if you look at this 2032, okay, so what's going to happen for your renewable? It is growing enormously. So if that is the case, so you cannot depend on the coal in 2032. You also depend on energy storage. So the install capacity today, as on today, if you look at it, it is very low. But if you see battery costs are keep on reducing over the years. So that's the reason if you see maybe by 2032, the cost of the energy storage, battery energy storage might be far less than comparing 2025. And another thing is that transmission sector also, like what I said, like in many places, if you see that existing infrastructure should be renewed or restructured. So for that, they also need like a 4.9 lakh crore investment is needed. Okay. Especially if you want to generate more renewable, especially from solar or wind. Okay. And so that's the reason if you see that there is a big grid upgrades are required or expected in the future. So as I already said, so energy storage is very important, not now, but in the future it might be very much needed. As the homes are equipped with electric vehicles, so you need also have a EV charging infrastructure and also the office premises, not only office building, but also industries, data center, etc., etc. So it also requires the load requirement might be changing. And if you see distribution side also, if you see it is going to be more smart, renewable based, and flexible also. Okay, so you also, if you see that everything they are converting to digital substation nowadays, especially if you see western side and Gulf side, so they are making most of the substations are digitized. So if this is the case, if everything is in place, so the demand response is possible as fast as you can expect. So that means this is so-called smart grid. So the smart grid is nothing but it's a combination of smarter demand, smarter supply, and demand response. So if everything is in place, then it is called as a smart grid. So you can able to achieve this in the near future. So motivation. So for this, motivation is very much needed. Why? Because so there is a lot of research is involved in this, especially if you see university R&D or military installation, city or community villages, public institution, commercial side, like a malls, a supermarket, hypermarket, remote communities. And if you look at islands, so islands also it's very much required. So that's the reason. And they also given like in which case they are strong, medium, and weak, and what is the ownership. Ownership means who is to take the complete ownership or partial ownership. So if you see the white color is ownership from the utility or the government, and the blue one is nothing but the ownership of the end user. So mostly if you see university R&D equal ownership, military almost 90% ownership, public institution almost 90%, commercial almost 90%. Remote community in island, it completely depends on utility or the government. So when you are talking about energy storage, the batteries are coming into picture first. So if you see the lithium ion or lead acid or sodium sulfur, So especially for the integrating the PV with the grid. So if you look at it, so frequency regulation and peak shaving and solar PV integration, these are the three important objectives of this energy storage. So if you have this energy storage, you are able to achieve these three activities when you are using with the renewable based grid. And especially if you see like they given the chart along with how long it can support, the capacity it can be available. For example, lithium ion for like almost 1 to 2 hours. Sodium nickel, if you see that 1 to 2 hours. Sodium sulfur, if you see more than 5 hours. Lead acid, it is ranging of less than 1 hour as well as 1 hour to 2 hours. So like that, it has available in various time durations. And if you look at it, uh, so mostly if you see that, so there is a lot of requirement, and if you see almost 60 megawatt is a requirement here. And I think the government is having a very good plan and a very good policies and regulations now. I think they are able to achieve in the next 5 to 8 years. So that is possible. So how it is possible? So they require flexibility of energy ecosystem. If you see that how you are able to achieve, including the energy storage. So you should also have a flexible generation like your smart generations, and you should also have a new infrastructure, and you should also have active customer consumers, and if the demand response is good, and along with that, if you have energy storage. The energy storage, if you see that it looks as the best alternative, non-invasive, less expensive, scalable. I mean, I'm talking about in 2030, not now, because now it may not be it might be expensive. Okay, now, but in the future, if you see that the price can be keep on decreasing, so in that case, I think you can easily able to achieve it. So, what are the applications of energy storage? So energy storage means you might have come across the battery energy storage, whatever you are using in your laboratory or in your EV, but not only for the particular application, but also for you can easily shift the energy. So and another thing is uh, you can easily charge the battery whenever there is excess in the renewable power plant. For example, you might have come across something like pumped energy storage. So pumped energy storage means whenever there is excess energy, you can pump the water to a highest level. And whenever there is no energy, so you can allow the water to flow through the tunnel so that you can generate the electricity using the turbine and the generator. So this is what the case. But instead of that, now if you see that you are able to store the energy in the battery whenever there is excess energy, especially the off-peak period. Okay. And if you see that in the peak period, suppose if it requires more energy than the generation, okay, demand is more than the generation, you are able to use the batteries. Whatever the charging batteries are you are charging, so the same energy you can reutilize it. And not only that, you can able to smooth it. Okay. For example, most of the renewable plants are like a intermittent. Intermittent means it's not constant. So unlike your thermal and nuclear power plant. So that's the reason if you see that this is not a smooth power flow. So in order to, if you want to smooth the power flow, this energy storage is very much required. And not only that, as far as the large end users are concerned, so you need to focus on rate optimization also. For example, you can store the electricity whenever the market price is low and consume it whenever the market price is high. So this is another biggest point whenever you are going with the energy storage. And another thing is like a microgrid, uh, especially for isolated grids. Okay, so if you are thinking about like island or something like that, so in such cases, if you see, storage is very important, because you cannot depend on the renewables heavily. And also, you cannot much depend on the diesel because now we are focusing on how to reduce the CO2 emissions. So mostly, if you see that by 2032 or 2030, mostly they want to remove diesel-based backup supports. So in that case, energy storage going to be a best alternative for this case. Another thing is like ancillary services, then investment purpose, peak shaving. These are all like a part of your power transmission and distribution system. So which is nothing but so where you are focusing on this particular cases. Either you are able to you are focusing on like providing or absorbing the active power as well as the reactive power because now you are using a renewable based sources, especially the inverter. So the inverter can act as a reactive power source. In case during the daytime it is able to supply the real power, and in case during the nighttime, especially for the PV, it can support the grid for reactive power supports. Okay, so this is also another important advantage. And peak shaving we already discussed. If you see that investment purpose also you can focus on it. Like whenever there is off peak time, you can store it, and during the peak time you can sell it. So that's a very good investment focused idea in this. So as far as the energy storage is concerned, so batteries are expensive, especially nowadays, whatever you are thinking now. And next thing is like solar. If you're focusing on solar, it requires a different kind of storage. So you need to work out on the storage price, and it should be small compared to the solar generation. So that's also a challenge. In fact, risk is involved. So you need to do some analysis. And current price, I already told you, like I'm not talking about the current scenario because I'm talking about 2030 scenario. So might be by that time it might be less. And you can think of like alternatives, like how you can store the energy alternating. So that is also another important factor which is coming into picture. So this price is like almost maybe 2-3 years back, I think so. It's not the current price for the lead acid battery. So if you look at the different applications, so what we worked when I was here in India, especially partner with the Nive, so we worked on energy storage plants, especially in Kaitar location. So where you have like a 200 kilowatt Micon wind energy generators were there. These are like 25 to 30 years old. And there is a sufficient land is also available between one wind turbine to another wind turbine. So they wanted to utilize the land space. So they have come up with this project called how we can install the solar PV along with the smart grid controller and energy storage. So this is what the scheme which they introduced in the year 2017, I think so. And it was there, and it is also in place now. So especially if you see there is a substation which is a 400 to 11 kV to 50 kilovolt ampere, especially which is connecting to the 11 kV transmission line. I think by that time when I was visiting, so there were a lot of restructuring was happening in that corridor. But I think now it has been almost completed, so you can able to pump a lot of wind power also now. But the only issue is that most of the wind turbines are very old. Okay, it is working beyond its life capacity, so that's also another challenge. So here, if you see that this project is focusing on this energy storage, you can see in the battery energy storage, and you can see that the wind is there, the solar is there. Along with that, it is a battery. So that means it is a kind of hybrid PV wind battery based energy power generation system, so that you can easily like smoothen the power output. So that's also possible. Because most of the time you might have heard that if it is not able to generate a sufficient power, So what they will do is like they will cut off the wind turbines. So instead of that, if you have this energy storage, you are able to smooth the power output. Second thing is, this is what the idea which I proposed when I was visited maybe 2 3 years back. Um or I think there was some scheme was happening. The government was funding to GCEK. So by the time we visited and we was discussing about some plans like installing the energy storage. So this was the plan, like 1 kilowatt solar grid tie inverter. So it could be installed in the rooftop of GCEK Kannur. And if you look at this, you also have a net metering system. Could be connected to the 1 kilowatt wind turbine grid tied inverter. And this is having like some RS-232 protocols, also communication protocol, and also you can see GPRS, TCP/IP, then Wi-Fi, Bluetooth. So all those communication or interfacing protocols also uh, to be planned. Along with that, you should also have a lab. So inside your lab, you can have like a small PV panel along with the MPPT based battery and DC to DC converter or charge controller along with the inverter. So you can also test like your new configuration. So whatever you develop inside your lab, and all these things, if you see that you are able to see it in the SCADA system, that means a bigger monitor or display. You can call it as a central control or monitoring center. So this was the idea which we proposed for different institutions in India, almost like 4 or 5 institutions we proposed. And if you look at it, like I think this was during the TechCube funding time we proposed. The next one is like what are the different advanced topics is happening. Maybe it may not be suitable for all the locations. So wherever you have like your offshore wind power plants, especially if you see that I think NIWE, National Institute of Wind Energy, recently if you see they have tested this offshore wind turbines near Dhanushkodi, the tip of that means near close to the Rameshwaram. So if you look at this, like maybe in the future, if we have like more offshore wind turbines, so how we can utilize this uh, excess energy, so that you can store it in the energy storage, okay, especially the battery energy storage, or you can use the water, okay, and you can just pump to the upper level. There's the pumped energy storage also. You can do that. But I'm not sure like which one might be having a scope in another 5 years. Then another thing is like you can also work on like a sustainable development goals, because these are the important nowadays. You might be knowing about SDGs starting from 1 to 17, and where especially the electrical or power engineers are focusing on SDG 7, affordable and clean energy, and SDG 13, which is nothing but climate action. Especially if you see that you cannot alone do it, so with a partnership, so that's called SDG 17. So partnership means like private, public, or industry, academia partnership like this. So this is also possible. This is one of the sample project which was done in the Turkish power grid with the help from the Aalborg University. This is another futuristic one. Like we are talking about energy storage, but the future energy storage is nothing but like hydrogen storage only. Because even now, if you see that Indian government, maybe almost 2 years back, I think they introduced the hydrogen-based cars also in Mumbai. I think Shri Nitin Gadkari, minister. So he introduced that. And in the futuristic way, if you think about it, maybe the flights, aeroplane also, maybe in the future, so they want to have a sustainable fuel. So I think this is one of the alternative options. So where you can work on like a hydrogen electrolyzer, and how you can use that hydrogen fuel cell and to drive this electric motor directly, okay, in the flights. And not only this, I think they are focusing on drones also. Nowadays, you might be knowing much about the drones. And drone also, if you see that they are focusing on this like a more hydrogen-based fuel instead of using a conventional one battery. So this is another area where you can work on it. It is also having a very good scope in the future. And not only that, because of the technology, okay, so you have like artificial intelligence now, big data analytics, like machine learning, deep learning, etc., etc. So now the data is nothing but another asset. So if you look at it, so you cannot work more on a conventional. Instead of that, you can focus on like how you can incorporate uh, the database analysis, okay, or market analysis, or electricity networks, or electricity cost prediction. So many things are there. So in fact, artificial intelligence is playing a very good role nowadays. So if you focus on this particular research also, I think it is going to be a futuristic one, because nowadays almost all the data is available now. Okay, and especially if you see how you can focus is like uh, many are working on like a SOC estimation, so state of charge estimation, and not only that, they are also working on like how long the battery life will be. Okay, so that also they are able to predict now by using the artificial intelligence or some optimization tools. So this is also another area where you can work, and there is a very good amount of research is possible in this area. And not only that, if you look at it, like most of the institutions, so I think you might be seeing government is giving a lot of funding, especially for equipping faculty, especially like non-CSE faculty, to get the exposure in the like computing areas like artificial intelligence, IoT, and data science related. So they are giving a lot of opportunities, even in NIT Surathkal, NIT Warangal, okay, even in now NIT Pondicherry, they are offering this particular course. Especially it is a free 6 months course. Maybe it's what do you say? It's a combination of both online as well as offline. Okay, so that is also now it's a step which is taken by the government, especially the central government. So you can get a lot of exposure in this particular area, and you can work on this data-based analytics tools, and how you can utilize this for the electrical and power engineering applications. Even if you see in my institution also, Amrita also, they have this particular setups are available. And currently, if you see that there is a lot of requirement for PhD as well. This is especially for master students. If you have any master students, so here we have a lot of openings, especially to work on uh, this futuristic technology. And we also have like two new labs are coming into picture. One is on drones, and another one is on artificial intelligence and IoT-based technologies. So if you see that now the research is also gradually transforming, you cannot say that you can work only on the converter, inverter, etc. So now the research is like a multidisciplinary, or you can say transdisciplinary research. So which is happening now, and the focus is more on how you can use the data, not only hardware but also how you can do the data analytics, and how you can optimize the power generation, or how you can predict the fault or condition monitoring or prognostics. So these are the some of the areas. If you see that, you can get a very good future scopes in the research, as well as you have chances of getting more publications in this also. So these are like a couple of areas where you can focus, and if you are masters, so it is the right time to step into this area, so that you can do the research or PhD in this particular domains. So with this, so I would like to thank the organization and organizers for giving this opportunity, and I'm ready to open for the discussion if you have any. I'm really sorry that you guys are like in vacation today, and I know that how difficult it is. And thanks for the patient listening, and support.
Thank you, Umashankar sir, for your presentation. It was indeed a very good insight to know that electric charging infrastructure is one among the, key areas that we need to focus, even in the world of AI and so on. So I would request the participants to, ask your questions. Sir is available for us. Please carry on. Meanwhile, sir, I would like to ask you a question like uh, looking at the charging technologies, like we have fast charging and so on. Is it, is there great amount of research going on to increase or decrease the charging time?
Yeah, actually, if you look at the charging infrastructure is concerned, so the research is happening more on what is it, the prediction, monitoring, and data analytics only. Because the charging infrastructure, if you see that is almost matured, and moreover, if you see that as of now, they are not much considering the green EV based, green energy based charging. Instead of that, I think most of the charging infrastructure what we have now is based on the electricity board supply only. So that means EV. So if that is the case, I think there is not much. What is it? Research is happening on this particular area, but whereas research is happening on the allied area called like how you can predict or condition monitor or prognostics or diagnostics. So those areas are like much. And not only that, how suppose if you have a charging infrastructure, for example, in Kannur in the highway, so something like how many vehicles are already there? Is there any traffic is there like in the charging station? So how you can predict which charging station is nearby, like when you are traveling in the highway from Cochin to what is it, Kasaragod, something like that. So how you can identify that? So those charge scheduling, or I can say that which is the nearest charging station. So those things only, it's really the research is really happening, and focusing on optimization and artificial intelligence tools. But I'm not sure about the research is really happening on focusing on the DC fast charging or AC charging, because I think it is almost mature and which is already in place.
Okay, I get it, sir. Then what about this swapping infrastructure? Uh, uh, when the swapping infrastructure becomes very popular, you mean to say that you're buying a vehicle means you're buying the body and the other parts. You're not buying the battery, right? And then the battery is being supplied by the
Company
uh,
itself.
yeah, company. Okay.
Even if
So
you take a two-wheeler like
mm,
bikes, e-bikes.
carry on, sir.
Okay. So even if you take e-bikes, like whatever they are using now, so if you carefully look at it, like some of them they are giving AMC, annual maintenance or something like that, or the battery will be under the care of the company itself. Okay, they'll be taking care. So you no need to buy anything. You can swap it. But swapping in order to the swapping should be happened, you should also have like a lot of swapping stations in the nearby, like near to your hometown or something like that. So that's a challenge now. So that's otherwise, if you see that nowadays they are going ahead with the like wired charging, right? So the wired charging is possible in your home itself. Otherwise, I'm seeing in the city, most of the places they have this swapping batteries also, so they are able to swap.
So in that case, how do you ensure the health of the battery that is getting swapped?
Yeah, that is anyway the company is taking care, right? So they are giving for like 2 years or 3 years AMC, so maintenance, annual maintenance charge. So if that is the case, if the battery is deteriorated, that means it is the life cycle is gone. Means then you can just throw away, or it's like a second life battery. You can use it for some other purpose. Even the research, yes, as you said, there is a research in second life use batteries is also happening. Especially how you can like instead of throwing away as a what is it waste, okay, instead of that you can how you can use the battery in energy storage application or in your house. So that is also not only research but business. So it's another kind of business is happening.
Okay, okay, thank you, sir. Participants, please comment, ask your questions.
I too understood that it is really very hard, especially Sunday evening.
Okay, then if there is no more questions from the participant side, I mean, Agil sir.
Okay. So, thank you very much, Umashankar sir. I would like to take this time to uh, give a vote of thanks to Umashankar sir. So, on behalf of the organizing committee, I extend our sincere gratitude to Dr. Umashankar for sharing his knowledge and expertise in this session. And we are truly thankful for your support and association. And we look forward to continue academic and professional collaboration in the future also. So thank you once again. Thank you, sir.
Thank you so much for this brotherly support for the last 10 years with the GCEK. And I'm looking forward to meet you all maybe in some good occasion of the conference. So thank you.
Oh, thank you, sir. Thank you so much. Dear participants, our valedictory function will start at 5:30. So I would request you to come back after a short break at 5:30 for the valedictory function. So in between, Agil sir, you want to add something regarding the feedback session and so on?
No, sir, I think we can have both feedback and voluntary function at 5:30
Yeah,
itself.
together. Okay, okay,
Yeah.
fine. So I request all the participants to be here at 5:30. The link will be active. So kindly have a short break and come back soon. Thank you so much.